Alright, well, hello, folks. My name's Cameron Nixon, and welcome back to Mesoscale Musings. Today is Thursday, March 25th, 2021, and we are going to have a nice little chat about what appears to be a fairly powerful severe weather setup over the southeastern United States with a high risk, level 5 of 5, issued by the Storm Prediction Center. So, as always, these discussions are for educational use only. These are not meant to serve as a point of information or decision making for anyone living in these areas. And yeah, today I've actually seen quite a bit of people very smarter than me and much more influential than myself sharing lots of convective allowing model output and helicity swaths and significant tornado parameter and all that fun stuff, and with all the pretty colors. But here, you can rest assured, we will do a very kosher deep dive into the mechanics that actually produce these storms and not regurgitate, if you will, the model solutions. So right now, let's take a look at our visible satellite imagery over the area. Lots of moisture here, lots of dense clouds, also some pockets of sunshine here. If we look a little bit closer, we got a lot of rumblies going on in kind of a what looks to be kind of a convergence zone. You can physically see some of the convergence going on down here. Lots of these because it is still early-ish morning. They're very likely to be elevated. However, some of them are showing signs of becoming surface-based. Even a tornado warning was just thrown out a little bit ago. So I could pull up radar and you can see the very spotty nature of some of these cells. You could actually even see some of them do have kind of like a rightward turn component. If you look close enough and look at the actual NexRads, you can see that they are taking on kind of curved appearances. Even though they are elevated, this is just indicative of a strongly sheared mid-level environment here. So very conducive for supercells, and we're obviously quickly destabilizing already from that morning stability here. In their wake, there is some very intriguing clear skies here, likely indicative of some drier air in the mid-levels, which we will chat about in just a second. But generally speaking, we do have that northward return of moisture into the southeast U.S., and some sort of kind of diffuse synoptic warm front here that a lot of these cells are riding. And then this is kind of a mid-level moisture convergence axis here that is evident bisecting this warm front. And if we scoop backwards a little bit, you can see another piece of forcing. This is actually kind of going to be our primary just off the deck forcing here, and is associated with a diffuse cold front here. If you look closely, it is very hard to define said cold front. There's definitely a couple wind shifts throughout here, a couple temperature dew point shifts, but it's hard to just look at a single place and say, oh, there's a cold front. You could do that with this mid-level feature, which is kind of intriguing. But it is kind of hard to find your cold front. So with all of these combined, again, we have your surface cold front and your mid-level, low mid-level cold front, which may or may not be actually associated with each other. And we have this band of forcing. A lot of these are very diffuse, and that's kind of going to be the word of the day. I think is that diffusivity, if you will, of your forcing, and that's not a good thing if you don't want severe weather. Because that will allow for a proliferation of cells that do not immediately grow upscale into mesoscale convective systems or QLCSs. So definitely already our forcing mechanisms are kind of their nature is that for discrete convection. We also have, again, that clearing here might suggest even the possibility of some warm sector diabatic heating induced, daytime heating induced storms that do develop out in here. Again, there's a lot of subtleties. I'm even seeing something new here that I didn't see before. There does seem to be another kind of band of forcing here. Perhaps they collide into each other. Perhaps anything can really happen at this point. It is unlikely that the surface cold front is going to be perfectly related or correlated with some of these mid-level features. So there really is quite a few opportunities for convection to arise. It is with this thick, heavy band of elevated convection forming right now. That does shed some concerns as to the northward extent of the moisture, but we can already see just north of this front, I've seen a 69 dew, and generally that sunny skies should help boost the convection available potential energy there throughout the day. So I'm not too worried about that. In the terms of hindering our convection here. So if we step out here, let's actually do a continental view and throw up some water vapor. Get rid of those surface obs. And what you can see is a ongoing, beautifully organized synoptic system here. You could start to see kind of the semblance of this kind of divergence, deformation. You can see kind of like this comet head-like feature starting to form here. This is going to be kind of the primary synoptic center here. You could also see a couple jet structures and literally a coupled jet structure. We have one jet stream here. You can see some descending motion. We're looking at water vapor and the level at which water vapor is the most dense in the atmosphere, and that is declining in altitude as we go down from kind of this feature into these warmer tones. We are quite literally descending through the atmosphere here. And then this is our ascent region, and this is some very strong ascent. As you can see, we go very quickly from these yellows, this dry air mass, to the more brighter whites and greens here. So lots of ascent going on here that is fueling this synoptic cyclone currently right now. Just to the south, you could see a very classic representation of the subtropical jet stream with that cirrus inside there. So we are just infringing on the subtropical jet territory. But the coupling of these jets, this jet stream here, with one up here, you could see kind of a descending motion again from the whites down into the yellows, and again an ascent up here. So there's evidently another kind of jet streak up here, and the coupling of these two is going to place kind of this low pressure center in the left exit of this one and the right entrance region of this one. Which is going to lead to a continued rapid strengthening of the system. So lots going on to support a very dynamically intense kind of scenario here, and we'll discuss the implications of that shortly. But right now, we could check out our actual observed profiles from our few southeastern U.S. ASOS sites, not ASOS, RAOB sites. And we could check out our Lake Charles sounding first. This really got my jaw dropping because we have almost dry adiabatic lapse rates here. This is just exceedingly rare for the southeast U.S. In a severe weather scenario like this. And that's just going to stockpile your cape above that. You can see we're 73 over 70 at the surface. And a little bit of warming here and a little bit of erosion of that cap, and we are good to go. Hodograph is already very long in the low levels and curved, and it's some fairly strong mid-layer shear. If you move closer, again, we analyze kind of that jet axis to be a little bit further west. I noticed if you move a little bit further west here, maybe take the Shreveport sounding, you can see the mid-levels of our hodograph start to amp up and are more take on more of a southerly component. Maybe we check DFW, yeah, and you can see much more powerful upper level flow here as we get into that jet axis, which will move over hodographs like this. So general trend would be for strengthening mid upper level flow here, which would more readily support supercells. And throughout the day, we're going to have an increase in low-level flow as kind of a mass response to the deepening of the system here. And we can kind of experiment with that. Just one solution here is the NAM, and we can see how closer to kind of this low feature here, we have an amplifying low-level wind pattern throughout the day as that system strengthens. What is really disturbing to me almost is this upper level instability here. Again, that this is very high end for this area. And what I did find was cool as you shift northward, you could literally see the impacts of ascent on the skew. So what this literally does, as you move upward, as you have rising motion and lift, you're quite literally going to lift this cap upward along your dry adiabats here. So we follow the stout cap here, and we lift it up. It moves up these dry adiabats. It cools dry adiabatically as we put that ascent onto this sounding here. So as we move up, you can see our cap moves up as well. And so this is what's happening currently right now is the impacts of ascent on the system is just lifting this cap off and allowing our parcel to actually attain buoyancy in that layer. So if you take the 73 over 70 here and kind of mentally adjust this sounding for that, you have what looks to be a pretty volatile low-level thermodynamic profile. We have over 100 joules per kilogram of 3-kilometer cape, very good for low-level updraft stretching. And this sounding itself, even before surface heating, has over 2,500 cape, very likely to a near surface-based parcel. So very potent environment here in terms of instability, and you can see a deep dry layer here, which is likely what is contributing to our clearing over here. Definitely evidence of some steep lapse rates here and some thick cape profiles. As we move further east, we could check out our Birmingham sounding. You can see the EML is a little bit more subdued. Our elevated mixed layer, our strong lapse rates is a little bit more subdued here. But we still have some pretty strong cape. Our photographs are quite a bit different as we move between the two. This one features a lot of warm air advection. You can see this is our inferred temperature advection here, showing some essentially our stronger veering is correlated with stronger synoptic temperature advections here. And that this should not be surprising because we were in kind of that warm air advection regime where we had that lifting front here and all these elevated storms ongoing. So this is not a surprising sounding to see with that. And later in the day, we will veer our low levels. It won't be this extreme, and we will kind of come closer to this kind of shape here. But the veering in our upper level flow will be a theme throughout the day because we will be we will be farther away from our mid-level jet forcing here. So that veering of our upper level jet actually is a good thing because that will lend to a little bit more curved photographs. Again, farther east over the day, we will have this stronger mid-level shear and stronger veering. So what else could we dive into? Let's kind of where we could see the impacts of our currently sampled elevated mix layer here and our steep lapse rates. Again, we got about what has been that Lake Charles sounding right here. We got that maximum in our lapse rates here. Very nearly dry adiabatic, considering we have the this is in the 700 to 500 millibar layer, and that's pretty high up there. So if we move this throughout the day, our jet stream our mid-level flow will likely kind of vect this up northeastward, and you can see that's essentially what happens with most of our the western portions of the area, Mississippi, western Tennessee, getting the bulk of that convective available potential energy most likely. And again, with our photographs being ever so slightly better, kind of in the eastern portion here. So let's play out as many scenarios as we can right now. Obviously, we do have currently destabilizing lower level profiles here with this convection ongoing, with it showing signs of rotation here. And judging by the proximity soundings that we did have at 12Z even, these would be readily capable of tornadic supercell structures. We got almost 40 knots of 0 to 1 kilometer shear in the Jackson sounding here. which is more than sufficient for significant tornadoes, perhaps even stronger than that, from the get-go. So obviously, concerning situation. Again, most of these steeper lapse rates and buoyancy are going to be confined most likely to the western portions of the outlook. So my guess is initially these storms may be particularly strong. And sort of quick to start producing tornadoes because of all that low-level buoyancy. But as they persist eastward, the enhanced hodographs from our more veered upper-level flow and the strengthening low-level wind fields from our system should lead to continued persistence of these supercells. So this is just one feature to give us tornadic supercells, and this is the one that is currently over the area right now. Very likely we will kind of refuel in the next few hours after the system passes, because we do have mostly sunny skies because of all that dry air aloft. And this is just going to continue to build the convective available potential energy for our next couple waves. And this is a little bit more of the tricky part. This is what I was mentioning. I'm still finding new features to look at every minute here. And it's this very diffuse kind of surface and just off the deck kind of boundaries here. And so these are very likely going to be our primary forcing providers for the day. And what is going to yield the lion's share of dangerous storms this afternoon. So we could check out, I'm actually going to use the NAM model exclusively for this analysis because the RAP, in my opinion, after lots of comparisons with our current soundings and the strength of our EML here, just was not resolving and handling this cape hardly much at all, and it was actually really neglecting the hodograph as well. It yielded a very underwhelming solution, and while that is, I guess, a possibility, it just did not reflect the what I'm seeing currently with our observations. The NAM was a little bit more close to this. I wish you'd go away, frowny face, so I could pick more variables. But in general, our surface-based cape with the NAM seems to be consistent with what we are seeing in observations, or what we were about 12Z. So we can we encountered an invalid response. What's going on? Put a lot of effort into this. Ooh boy, we're having some fun here. Is this my internet connection? I'm sorry, folks. This Twitter load. Twitter loads. Oh no. Okay, well, let's check out pivotal weather instead, and try to find some of the features that I was wanting to analyze here. But we can let's do relative humidity here. We can look a little bit closer at how the NAM tends to what the NAM wants to do with some of these low-level and mid-level features. Here is again that mid-level, low-level convergence zone that we were just looking at. Let's see if this loads again. Nope, it doesn't. On satellite, coincident with the surface front. So what we could do, let's take our 3 here. We can see that this is the main zone of just off the deck confluence. Again, this is 850 millibars. And we can go down to the surface and see our theta E axis. And that is largely still heading out of Texas at this time. So there's a difference in location between these two boundaries. And because both of these can serve for the initiation of storms today, that is just one reason why there could be multiple rounds of convective initiation and supercells that develop from these. So again, looking at our first round here that's currently ongoing, potential second round from one or both of these mid-level confluence features that we saw, and then potentially even a third round from our surface front here. So this is all these rounds, if you will, are going to kind of ratchet up the probability that a certain area near the high or moderate risk zone gets supercells capable of producing tornadoes. So let's just take a look at what the environment could be near once this confluence zone moves into the area of steep lapse rates, because that's very likely to be when convection does initiate somewhere midday. So let's pluck a sounding here, and we are extremely contaminated, but that actually is somewhat realistic because we have very strong lift in this area, but that's very likely due to some convection there. So here's a little bit better of a sounding here. We do have, again, that steep lapse rate here being modeled, leading to what looks to be a pretty realistic amount of cape here. 73 over 70 also seems pretty realistic compared to what we were seeing. I think this is the exact Lake Charles ob. And a hodograph that features very strong low-level flow, rather weak mid-level flow, that there is some indication from the NAM at least that this might, we could pluck a couple more soundings around the area, this might lead to a potential messiness in the initial initiation of cells along that line. But should rapidly move off that line with 50 knot motions there, and then start to use some better hodographs just east of there. But our low level shear, again, our over 40 knots here, should support rapid tornadogenesis in some of these cells. It's just the only question is how many of these cells we do get here from this zone here, and how they might interact with each other. One very distinct possibility, I know the Tennessee region and above or northward were also analyzed in a pretty substantial risk for severe storms. And really synoptically, that area is beautiful because we are very close. We're still not working here. We're still very close to the bulk of our kind of synoptic system here, and close to our strong mid-level forcing here. But what might happen, and the NAM's actually displaying this, and we can go eastward a little bit, is that a lot of this early convection kind of just takes over and blocks this region from further moisture return and from the low-level kinematics there. So really kind of a boomer bust northward of, say, kind of the Tennessee border here. In terms of what actually might happen here, because if we do get a lot of convection to proliferate from this initial round, that is going to block a lot of this parameter space from reaching up here. I don't think that EML should be a problem. That should continue to float northward throughout the day. We would have a potentially large amount of cape should we get the moisture up here. But it is looking at this moment, especially with our 12Z runs here, increasingly less likely to happen. So we could continue to follow such a storm later throughout the day. You could see our 850 fields, again, just dramatically strengthened throughout the day with the strengthening of our synoptic cyclone here. So we could just pluck, let's throw up some cape here. Let's do some mixed layer cape. Let's pluck somewhere in the Alabama region. And this is what we got going on. We got our strengthening mid and upper level flow in response to the approaching jet here. Just a very strong low curvature here. Really not much preventing this sounding from being very impactful, again, except for storm mode here. So yeah, really, and this is kind of just your self-evident synoptic environments for powerful tornado outbreaks. Like there's not really that much more to glean from this. This is what you see in textbooks, and this is what gives you your once or twice a decade kind of severe weather environments. So we can continue rolling this out, see what the environment might look like later on in the evening. Still lots of cape out there to play with. Again, kind of continues the theme of very favorable environments here. So that is really all I want to talk about, I believe, and I hope you learned something from this and are now encouraged and inspired to look at the atmosphere in a deeper fashion, and stop sharing those cam outputs for me. Thanks, guys, and I appreciate you watching the video. And also, I want you to check out Trey Greenwood's channel, his Convective Chronicles. I've been learning a lot from those, especially in the terms of synoptic conditions leading to this environment. So he goes into a lot of detail on those. And then Andrew Pritchard is also doing a kind of a weekly chase forecast. So if you are a chaser or interested in documenting photogenic storms, I also highly recommend you all check that one out. So definitely sit back, watch, learn a lot from this. This has the potential to be one of those days that we don't forget for a while, and that we do learn quite a bit from. So with that, have a great afternoon, folks.